Okay, in this video we will learn about distance of two vectors and length of a vector. Let us start with definition. Basically, it will give us the formula for the distance. So the distance of two vectors u and v. So how do we denote this? This is going to be a number, positive number. We are going to denote it, which we denote by d of u and v is given by okay, so this is a number, d, u, and v. Well, you say, is that a two-dimensional case or three-dimensional? If it is two-dimensional, then u is going to have two components, and v is going to have two components. And the distance is going to be, this is important, subtract the first components, score it, subtract the second components, score it, add these guys, and then find the square root of that. This is when we have vectors in R2. How about vectors in R3? Well, for vectors in R3, we have three components. But what we basically do is exactly same thing. Subtract the corresponding components will be u1 minus v1, u2 minus v2, and u3 minus v3. Square them, each one, add them, and then find the square root. And this is the distance for the vectors in R3. This is the formula you have to remember, you have to keep in mind, and you have to use. But there is one nice point to remember is that, well, have you seen this formula before? Looks like I am squaring, adding, and then square root. This is exactly Pythagorean Theorem. And what you need to know here is that basically the distance of two vectors u and v is the distance of their endpoints. What does that mean? It means that if you have vector v here, doesn't matter if it is in two-dimensional or three-dimensional, u here, then the distance of uv is basically distance of these 2 points. So let's say we are in two-dimensional case, then you have, remember the coordinates of the end point is the same as the components of the vector. Yes, so here basically we have 2 points here and here, and we want to find the distance. Well, what do? We form a right triangle here to here. The length of this one is the difference of the second component. So in this case, v2 minus u2, and here is the difference of the first component, so v1 minus u1. Well, then the length of this guy is going to be this part is squared, add and find the square root. This is Pythagorean theorem. It is exactly v2 minus u2 squared plus v1 minus u1 squared. This is exactly where the formula comes from. But, well, You just remember the formula. Whenever someone asks you to find the distance, then you find the use the formula and find it. Well, this is the distance of 2 points. How about length? 2 vectors. How about length of a vector? So the length of a vector u is the distance of the origin or the zero vector from u. Well, the notation we use for that, this is the notation. This means the length of vector u. And by this, what this says is that this is the distance of zero vector and the vector u. But what does it mean? It means that subtract the component. Remember, the zero vector has 0, 0 component, or in three-dimensional 0, 0, 0 components. So what you do is u1 minus 0 is u1 squared, u2 minus 0 u2 squared, and that gives us the length. Well, this is when u is a vector from R2. How about for vector in R3? The same story goes along, and we have the length of such vector. This is square each component, add them, and find the square root. That's the length of the given vector. Before we go, let's just do some examples. Find, well, the first one is find this 3, negative 4, and the second one is find this 1, 2, negative 2. Well, you have to know now the notation. Double line here and there at the beginning, at the end, means that the length, and it is given by square each component and add them, then find the square root. This means we have 9 plus square of negative 4 is 16, so I have root 25, and square root of 25, the number when you multiply to itself you get 25 is 5. How about this one? Well, square each component and add them, find the square root. So here I have 1 squared is 1, 2 squared is 4, negative 2 squared is another 4. Well, you add those ones first, then 4 plus 4 is 8, plus 1 is 9, square root of 9 is 3. The length of this vector is 3, the length of this vector is 5.